So let's say we have this equation. Find the vertex, focus, equation of directrix, equation of axis of symmetry, length of lattice rectum of the parabola y minus 2 squared equals 4x minus 3. First thing to note here is that this is not centered at the origin. There is a shift of this parabola quite like this. So the vertex is shifted. You can see there is a shift on the x-axis and the y-axis. So the vertex is here, 3 comma 2, and there is no negative sign here, so you can go ahead and do a rough sketch and see the shape of the curve. You can see that the focus should be somewhere here. Focus is a point towards which the curve bends, and the directrix should be right behind it somewhere, right? So it should be somewhere here. So you can sketch and try to find out the focus, the directrix, but to avoid any mistakes, I will just go ahead and show you a method to follow. You can first go ahead and kind of reduce this to the standard structure we had, and I'm going to use uppercase letters so that it's a bit easier to distinguish between this y and the equation that is centered at the origin. So you can see here the 4p is equal to the 4. 4p is equal to 4, and so we have p is equal to 1. It's a positively focused curve, so it should be somewhere focused like that. And I have used the idea here that y is representing y minus 2, and x, the uppercase x, is representing x minus 3. So the vertex of this parabola is, if it was centered at 0, 0, it would have been 0, 0, but this is not centered at 0, 0. So how you can process this is the capital Y would have been a 0, and so y minus 2 is equal to 0, so the y value we have is a 2. The x value should have been 0 for this equation, so x minus 3 gives us x is equal to 3. So the center, the vertex here is 3 comma 2. So here I've just represented, like I've used the graph for the standard form, the origin focused one, to represent this one. The focus has the form for this case, if you remember, it was something like p comma 0, right? But in our case, the x is equal to p and the y is equal to 0, right? And we have used x minus 3 is equal to p, and the y is y minus 2 is equal to 0. And so the p here was 1, right? We calculated that out. So x is equal to 3 plus 1, and y is equal to 2. So we have 4. So 4 comma 2. I'll go ahead and label that on the diagram so it's easier to understand. You can see this 3, 2. The focus is a point here, which is 4, 2. It's same value on the y-axis, and it's just shifted front in the x-axis. The equation of directrix is, I'll go ahead and compare that again. So it should have the form x plus a is equal to 0, right? And in our case, we have a x minus 3 plus 1 is equal to 0. So my equation is x is equal to 2, which does make sense. As you can see here, let me use a different color to bring in the directrix. So the directrix is one value behind on the x, right? So you can see it's 1 behind on the x. And similarly, the equation of axis, or axis of symmetry, equation of axis here is y is equal to 0, which gives us y minus 2 is equal to 0, so y is equal to 2. So the axis of symmetry here is this line, y is equal to 2. Y is equal to 2. And finally, we have the length of the lattice rectum. So length of lattice rectum. This is, if you remember, 4p, and our p value here was 1. So let's go ahead and just use that. 4 times 1. This is not a negative value, so the length of the lattice rectum is 4. If we wanted to look at that on the diagram, it would be that from here to here, this whole length is 4. Now let's say we have another question of this form. Find the vertex, focus, directrix, axis of symmetry, and length of lattice rectum for the parabola of this form. Now this is the general equation, right? It's the general equation for second degree. So what we would have to do is convert this into the standard form. And so let's go ahead and do that. Let's first complete the square. And so I add a term here, subtract a term, and everything else remains same. This is just completing the square. As you can see, this term is 0. And so we can have an equation y minus 1 squared minus 4 minus 3 minus 1, so it's a negative 4 is equal to 0. We can rearrange this to have this form, 4x plus 1. Right, so that's the equation of the parabola in the standard form. So it's always useful to convert it to the standard form. The rest just follows from what we just did a while back here. So I'm just going to display the workings here. The vertex is minus 1 and 1 if you set each of these equal to 0. The focus here is 0, 1. And that just comes from the idea that, y squared equals x squared looks like this and has the focus a comma 0. So if x is equal to a, then what we can do is x plus 1 is equal to, p. We've been using p here. So p here is 4p, right? So p is equal to 1. So this is what you have. So x is equal to 0, and the y remains the same. Y is equal to 1. So we can basically use this idea, right? We can use the standard equation without any shift and interpret an equation with the shift. So you can work out the rest in the same manner. This is just capital X equals 0, and so we substitute x plus x plus a is equal to 0, right? So x plus p is equal to 0, and the p here is 1, right? So you have x plus 1 is equal to 0, which gives you this thing. And similarly, it follows the same pattern. So these are the solutions.